Hello everyone, thanks for staying back. It's fag end of the day. My name is Sreenu. I work for a mobile development team within McAfee. I've been a long McAfee employee, worked for over 12 years. I have another colleague of mine, Davis, who is also attending. I'll talk to you today about content security framework within Tizen. A brief agenda. What is this content security framework? Some of the architecture and design concepts, right? And how the content security framework really uses the security engine to provide security within the Tizen platform. The couple of security engines that I would introduce to you. One is like the scan engine and the site engine, as well as the APIs behind them and the usage. And finally, we'll do a recap of what I've presented. When we were talking about Tizen and security within Tizen, right? One of the things that content security framework provides is a measure that allows to combat malware within in the platform itself, in the Tizen platform itself, right? And how do we do that? Content security framework is it's part of the security component within the Tizen stack. This is a picture that you probably would have seen multiple times, right? What does CSF really contain? It does two things. It gives a set of APIs, right, which higher level components or applications can use to basically provide security. When I say security, it's basically two things. It can scan content, right? It can scan apps. It can scan data, as well as it can scan the URLs, right? And how does it do that? It also does something called plugin management. As I go through my presentation, I'll show you what these plugins are. Plugins are pretty much the security engines that security vendors develop, right? And CSF basically loads these plugins to either scan data or scan URLs. Essentially, a takeaway from this is it's a set of APIs. It allows you to do plugin management, and apart from that. This is part of the Tizen framework as open source. So it has test kits. It has stub engines. What I mean by that, if there is no security engine available on the device, it basically returns with no engine available, right? It's just like a stubbed engine sort of implementation. And there's also documentation available about the framework. A little bit how it is used, right? Different system applications, right? Like installer, application launcher, emailer, message handler. All these they can call into. They basically implement the interfaces, right? And these security interfaces, right, or the content security framework which has these interfaces, they load the engine. The security engine which is available as a plugin. So what really happens when security vendors provide these engines, they ship it as part of their app, and the system installer, what it does is it provides it creates a symbol link and makes it available, right? And when say for example installer, application launcher, or emailer, it wants to scan content or scan or a browser wants to scan a URL, it basically calls to the APIs of the security framework, which in turn loads the engine, and the engine basically does the scan of the content or data or URL, right? So it is basically two parts, right? The vendors develop the security engines, which help in actually performing the real action of scanning the content as well as the URLs. Just a little bit of explanation about that. It is just the security component within the core of the Tizen stack that is expanded to include the content security framework, right? That is what helps in providing the security features, which are exposed as APIs, where the higher level framework or the applications can call these APIs to do the scanning. But as I was mentioning, it uses the engines provided by the security vendors to do the actual scanning. This is just like an extension to show that the scan library or the security engine, all I'm using them synonymously, right? The core security component that is part of Tizen, it has the security framework which expands for security, right? It provides APIs for higher level applications to basically call those APIs. It is very simple for the applications to like put it in and call the APIs, and they in turn load the engine or the scan libraries dynamically, right, to perform the actual scan. It's just what I've said, right, which provides little more details, right? It does two things in terms of the implementation. One is provides APIs to the higher level applications, right, and also it also like gives interfaces for vendors to implement in their security engines, right? So when the application calls for a scan, it calls the API within the CSF. CSF loads the plugin or the security engine, and then basically does the scan, right? And where there's also like a stubbed implementation available, where it is when there is no real engine available, it returns back. So in terms of like what were the design concepts that we thought about, right, when we built CSF, right? One was to make sure it is like it's a lightweight implementation, right, so that it is mainly OS friendly, right? It enables applications can initiate the scan, right, so that it is it's simple, right? So it's no overhead of like hooking into file system. In traditional PC world, right, when you try to scan, right, you go lower level in the stack, right, which is not the case here, right? It is no file system hooking, no going lower level into the stack. It is just an API that the applications would call, right, and the engines does what they have to do, right? And also it is the system applications have they can scan when they want, right? So that actually leads to this like the action driven sort of a concept. It is not like based on the user action, right? System applications decide when to scan, right? It is left to the application, right, to balance, right, security versus performance, right? Because generally, like it is when you talk about security or when you talk about scan, right, the things that immediately comes to people's mind is about how is the performance going to be, right? So that is taken care of in the application. And there are like standard interfaces that are available, right? Both for the applications, it is I'll show you a simple set of APIs that application can use, right? To just which are just like scan files, scan data, right? And they're also like basically there is documentation available in the CSF framework, right? Which any like security vendors can implement to consume those APIs in their specific part of the plugin or the engines. So to summarize, it is it is basically like it's lightweight, it's mainly action driven, and the interfaces are pretty standard. So when I was talking about security engines, they're essentially like there are two types of engines that I'm talking about, right? Which mainly are developed by any vendor, right? What the scan engine provides, or should provide, is it should have the ability to scan apps, scan files, scan content, right? And it does two things, right? It can do like content inspection, or it can also do like malware scanning. The other part is what I call is the site engine, right? It provide reputation about an URL, right? When user is accessing an URL, right, it can tell it's a good URL or it's a bad URL, right? It can provide the category of the URL, right? Whether it is like a porn site, whether it is like a malicious website, whether it is like a gambling website, things like that, right? And policies can be defined, right? You can define the policy. Okay, if it is the risk level is this, I'll block the site. Otherwise, I won't, right? So that is also like those APIs are available. Just to summarize what I have said, right? Scan engine, it provides the ability to scan content, right? It could be like file data, right? It detects like different types of malware, right? And as we all know, right, it is like it connects to, say, the vendor's cloud, right, for to get like latest signatures, right? That is just like an information. It's more like vendor specific. Each vendor has their own specific implementation about that, right? Site engine is basically I call it a URL security agent, right? It provides information about reputation of the URL, right? And also like it can based on the policy that you set, you can either block the URL or say this is a good URL. You can go ahead and browse, right? Yeah.
The scan engine, does it work offline, or is this an implementation detail of the engine? You wrote that it connects to the cloud.
Yeah, so that is all. This is nothing to do with. This is to give everyone more detail about the scan engine, right? Scan engine is individual vendors implementation, right? It is like in your traditional PC world or even in mobile world, right? When I say it connects to the cloud, to get the latest signatures, right? Latest, right? Right. It is just like I just gave you a framework or an idea of what exactly happens, right? Because if I just tell you content security framework, it does not give you enough details about what is exactly happening, right, with the framework.
Well, maybe I'll hold that question later on.
Sure.
When you say content of the website, content of an executable, content of data, is it signature only? Is it stateless? So are you just providing APIs that people can use those to implement their own respective?
Yes.
It seems to me like an antivirus agent.
Correct. It's
yeah.
Really what it is. Yeah, it is.
Right.
It is.
So you're providing the APIs.
Right.
That they can access to write custom antivirus engine for
Tizen. Yes. Yes. Okay, this is just like little more detail about so that you can appreciate what happens, right? With this is also like very vendor specific implementation on how they want to implement the scan engine, right? It should, in my mind, it should have some content and context sensitive analysis, right? The client applications, they can control, right, when to call a scan, right? They can do it like before rendering HTML page, before executing the JavaScript, right? Or when an application installer does, right? We can do it whether it's before invoked, after invoked. I also have a slide which shows like an use case examples of where we recommend that it could be called and where it could be called optionally too, right? This client applications, right? Any application, they can provide the scan engine with like pre-processed data or like a data type, right? Whether it is with following up the data type examples, right? HTML, URL, text, JavaScript, right? And as I was mentioning before, right, advantage over traditional security, right? It is like no low-level file system hooking, right? So this sort of like basically like encapsulates all the complexity.
So it's only about the app layer. You can't go down into the system. I think that you have something that got into the safe memory. You're not going to
whether there is something in the memory.
Yeah, yeah.
It can scan memory too, right? But it's saying what I'm saying is right. It does not need, each of the application does not need to hook into the file system. So this is just like one example of, right, how the scanning can be done, right? Any caller application, they implement the scan API, right? And get whenever there is like an infected content, they get the message, and they can show whether like they can block the content, right, or they can give the user the choice to what to do, right? As I mentioned previously, it also like you can specify the content data type, and also like definitely like better user experience. Like for application can control when to do what. They can get handle back what action to take when. So a simple example, right? When a user selects a link on a mobile device, right? It goes to the internet, downloads the file, right? When it downloads the file, the scan engine scans the file, right? And when the malware is detected, it gets deleted, and the page gets displayed without that malware. That is one use case. Another use case is, right, you either same thing happens, and then you like the application can give the choice to the user, right, depending upon the type of malware, right? If it is like severe versus not severe, if you know that it's malware and it's bad for the user, you can just block it. Otherwise, you can give the choice to the user whether they can remove it or they can let it go with the user wants to go with it. Right? So this is some like use cases I mentioned before, right? That I would show you. Like for example, different callers like email client, browser, installer, or application launcher, or messenger, right? They have a specific data to be scanned, right? What are the specific data types, right? O is optional, R is recommended, right? Like for example, on email client, you can do it like before rendering, right? On browser also before rendering. Installer, application launcher, you can do it like before invoking, right? That way it is like more secure. So this is one like the APIs that I was talking to you about, right? There are a set of APIs for like scan engine as well as the site engine, right? That the framework provides, right? Which are like could be called by the applications themselves, right? It's library open, close, like very self-explanatory, right? It is just allows you to initialize the handle, close the handle, right? You can always get the last error, right? What happens for that specific library instance, right? A couple of functions, which TCS is nothing but like Tizen Content Security, right? And scan data is like self-explanatory. Scan file it scans like application data and scans the file, right? This is just like an example of how you declare your handles, you do your declarations, right? Then you like open your library handle, right? Then you do what I just showed, like an scan data. You can use a scan file as well. Then you process your scan result, right, for you, which helps you to take action, and then you like do an just free up the library, right? So this helps you encompass like the scan, right? The next one is about this site engine. This is about like what you can do with your URLs, right? This pretty similar. You have like a specific code to like initiate the library, right? you create like an configuration, then create a policy. Policy is basically nothing but you can define these URLs I'm going to block. These URLs are good, right?
Just on the security keys there, would each application need to have one? Or could it be system-wide?
It is system wide. It is one for the site engine.
Sorry.
One for say like one vendor, I would say one OEM.
Okay. So if an OEM decides to make a device and hires a specific vendor to provide it,
Yes.
they will get that key.
Yes.
And would the API, would they put in a specific global file and the API, the library would load it?
Yes.
Or do they have to modify each application?
No. It is one location.
Okay.
Cool. That then there is like functions to like look up the URL. Look up URL is just to find out what does that what can I do with this URL, right? Should I block? Should I not block? Sure.
A mention was made of the signature.
Okay.
Is that signature something that is locally resident, or is that something that is acquired through a handshake to prevent any possibility of somebody spoofing it, or
The signature that I mentioned above.
OEM signature?
Oh, the OEM. You're talking about the key here, or
Yes.
So that is basically like shared. Like one implementation could be it is a key that is shared, say with an OEM vendor, and it is there on like an security vendor server, right? So it is.
So is there a protocol defined in requesting and getting that, and making sure somebody else in between doesn't interject and?
Correct. There is like an
Because, the thing about shared keys is they are wonderful until they get
compromised.
stolen and compromised.
Correct,
and then
correct.
they're useless.
Correct. So there is.
You're doing a handshake with maybe a public-private key exchange of some sort.
So it is. We have like an key and ID pair. This is also like that is shared with the OEM, right? And it is like always when it connects to the server, we know that it can be trusted, right? And that implementation could be like.
But it is a string, right? It is a string. So kind of two questions come.
Sure.
What is happening to it, or how is it treated during communication?
Okay.
B, when it has been communicated, where exactly is it sitting on your system? Is it sitting in a secure location? Is it sitting maybe protected by the key of a TPM in a blob or something? Kind of two questions.
Actually, this is entry should be vendor specific. It's not. It should not be covered by the framework. So framework only provides this parameter for vendors to support. This is actually optional. So if the vendor user can choose the implement this mechanism inside their plugin, which is which is owned by the security vendor. It's not owned by Tizen.
So the handshake is not standardized. I think that's
It's not standardized.
Yes.
So it's defined by the security vendor.
So if it is not standardized, defined by the vendor, how does the receiving end know how to decrypt it and
Because
make
the
meaning?
framework doesn't decrypt this. Because the plugin does the job.
So from what I understand, correct me if I'm wrong, we're defining an API for Tizen for applications and other system services to use. Now, each OEM would have a contract with a vendor that provides not only the cloud information, the security keys, etc., but also the engine that goes behind. Right?
No, I
And that
understand
engine
that.
would take care of the downloading, decrypting, verification of its own data.
Right, but at the end of the day, whatever that individual vendor that is communicating with the server, there needs to be a mutual understanding of the format of the content.
Yes,
and,
but
and the handshake. So there needs to be some understanding. I realize it's not a standard per se, but
it just as long as the engine verifies the server
Yeah.
to guarantee the integrity of the data from the server all the way to the device.
so what is that method of verification? There needs to be method, right? Every vendor is not going to have their own method of
I don't think that, I really do not see why that would need to be standardized. I mean, it could be just an HTTPS download with the verification.
Correct.
But it could be something. I just don't see why.
I was just saying, you know, just if there's an opportunity for spoofing that information, and that's another conversation.
Sure. But I would hope that the security vendor knows how to do secure downloads.
Okay.
Thank you very much.
That's okay. You're welcome. So after we look up the URL, then it is, as I was mentioning, right? It is you can define the policy what to do with the URL. Once URL is browsed, your policy you can check against the policy and take appropriate action, right? Either you basically you filter the bad URL or block the URL, right? That is you can show and block page, right? It traditionally is very similar to what you see on web protection, right? On PC world, right? Exactly very similar concept, but it just happens on Tizen too, right? And or depending upon if your policy is violated, you filter that. If otherwise, you allow the good URL to get browsed through, right?
Filter by various groups. Like say you have one set of folks that you would want to be able to go out to certain sites, and then you have another set of folks that they don't need to be going out there to something that you filtered on both. Or
See, the policy is left to individuals' implementation, right? But the API does provide, right? API does provide, say, the risk level of a site, right? Policies can you can define your own policy, right? For example, this is a couple of examples of how do you create you can classify the different categories of different sites, right? And also to your question, right? You can define in your policy what to do, right? You can, if you want to know the risk level of a site, you can get it from the API, right? And then you can define your own policy, right? So these are some these are certain callback functions also that the framework provides. That way that this does not limit any application, right, to make the callback mechanism to be HTTP stack dependent, right? So it can be independent. You can allow the caller to they customize their own HTTP calls, and you have set of callback methods that are available, right? Where you have a set method function, send function, receive function, right? Where you can define whether it's it will tell you whether it's post or get, right? What is the URL that whether it is HTTP or HTTPS URL. This was one thing that I was telling about, right? Where you can just when the policies get violated, right? You can block the page. You can intercept and stop the navigation to that site, right? There's complete control or how you can provide user experience, right? So to summarize what all I have said, right? CSF basically contains it has an standard set of APIs, right? And it also does allow for plugin management. Plugins are basically the security engines. Apart from that, CSF also contains test kits, stub engines, as well as documentation. It is, as I said, is a part of the security component in the Tizen stack, right? It provides plugin management, right? The engines, right? The vendor security engines or plugins, they implement the interfaces, right, to perform data as well as URL scans. And system apps basically like call into CSF, right, for scanning URLs and data. And they basically like load the security engines, which are actually like when they're put on the device, like the system installer actually creates a symbol line, right, and which will help the CSF to load the engines. We also talked about like the design concepts that went through in building CSF, right, being like lightweight, action driven, and a standard set of interfaces, right. And we also talked a little bit about how this security is like inbuilt within Tizen, and what exactly happens in the use of the content security framework, where you have the scan engine and site engine, and I have given you a glimpse of what APIs these have and how you can use them. That summarizes what I wanted to talk about content security framework. So I don't have gifts like what Cedric had to give away, but I can definitely, we have Tizen t-shirts, we have Tizen conference coming up in May, which will be again talking about CSF, but I can help answer any questions that you have. Yes, Cedric.
Yeah, just a question is,
Sure.
do you have any tool or any other section on how to automatically verify that an application has been using correctly in the right place, so the CSF API?
So we have test kits that are there that are available to test it, right? But Davis, do we have anything like you're looking for more something automated, right?
I was thinking more like LVM static analyzer that would be just saying here you are using the wrong call, you are forgetting to call the CSF here, or maybe you need to check that one. I just like a kind of idea that may.
Yeah.
The auto verification is only for the type provided by security vendor.
No, I was
for
thinking more
the
on
application. Currently, we don't have automation tool for that.
Yeah.
And we have a bunch of reference design because this is really related with how you want to implement. Because some of the application we may want to implement the scanning asynchronously, but some of them may want to scan it synchronously. So basically, this is totally depends on how you want to represent the UI to user more friendly, right? So
Okay.
yeah. So currently we don't have a short answer.
Anything you're working on?
Something you can definitely look into, but not currently being worked on.
What was it?
Oh, I can make another question.
I'll remember
I
what
was
it was.
wondering if you have also any plan to integrate it in the toolkit. Or
That was my question. Thank you.
sorry, it did slip to me.
Yeah.
So, do you have any plan to integrate it in the toolkit, in the native toolkit anywhere, or so that the application doesn't need to do that much?
For example, there is a native API for networking, right?
Yes.
So, is there any plans to work on with the native toolkit and make it integrated there, or will the applications need to specifically call the new framework?
Because that is also like could be specific to OEM, right? Because this framework is available, right? It could theoretically be called in the native, right? Right, but it's a question of like whether it is built into that, right? It is it.
Let me ask a different question first, and then we go back to that one. Have you guys worked on trying to, or integrating the CSF into the existing applications? For example, the sample web browser or the mail reader. Has any work been done to integrate the content security framework into those applications?
It is ongoing currently.
It is ongoing.
Yes.
So the sample applications will ship soon.
Yes.
With CSF enabled.
Correct.
Why can't we do the same for the toolkits? For the toolkit specifically, the native one.
Yeah, specific to CSF, I don't see any constraint, right? But it's more, I think, dependent on the device manufacturer, right? whether to incorporate that into the native toolkit.
I think it's a
Theoretically.
topic for us to
Yeah,
discuss,
discuss,
further
yeah.
and figure out how
Yes,
to do this.
how to do, yeah.
What is the toolkit? UI toolkit or
Well,
SDK?
Well, any application that will do a download should be using another toolkit, so it will make sense to, from my point of view, to have CSF already inside the toolkit when we have already API to do network, which is for the SDK.
Yeah, CSF framework already inside the Tizen platform.
Yeah.
Yeah. So CSF should be part of the Tizen platform, which is not guaranteed API. Is it guaranteed API? Should be
It's an
guaranteed.
API, so yeah,
Yes.
obviously
Yeah,
that,
yeah. We have developed the API, but
Yeah.
I think that may not be, for example, advertised for the developers.
Because it seems like the target applications are like browsers, system applications, so
Yeah,
obviously you're not
for
expecting
example,
every
you can-
user who's writing an application
To be honest,
level
you tell
one.
me, but you're the security expert guys here, but shouldn't most applications be doing security checks?
They can.
I
They can,
think
theoretically,
as
yes.
soon as you're doing downloads from website, you should be doing some security check. I mean, you're doing an ebook reader, you're downloading ebooks from the website, it will make sense to pass it through CSL.
At the moment, there's no virus engine.
Yeah. Of course, even
No agents, just
even if
one
there is no
framework.
engine, the application should be doing it anyway.
Well, if there's no engine, it's just going to accept everything.
There
Yeah.
are two levels, right? There are two levels. One is you're sort of saying, for good measure, use these APIs to make sure if you're downloading something. But on the second level, you also need a system-wide, so there's kind of that kind of a layer of security, as
That
you
is
say.
the job of the OEM to do the engine backend correctly.
Well, it's not a matter of engine backend. You need something system-wide. So, for example, let's say if you have here we're talking about applications which are good applications, good citizens. They are checking these APIs. What about a virus that comes in and its job is to wreak havoc? How do you protect against that? Obviously, it couldn't care less about these APIs.
Yeah,
so there needs to be something system-wide
Yeah,
that provides you, so you could have that as a separate application. Like in the past, McAfee has had antivirus applications you install, or it could be part of the platform. So that's a decision that the architects would need to make at what
Yes.
level that is provided.
Yeah, I totally agree. I just think that we were discussing different things. Yeah, I totally agree on that level. I think that then we just need to look into how to integrate with the native toolkit, but also make sure that the web runtime is using it. Especially the web runtime needs to be hooked into the CSF.
And the reason why you were talking about native toolkit is to, one thing I'm thinking is to limit the amount of implementation that each apps have to do, right?
Yeah, I mean, if we have a networking API that just downloads stuff, it should be integrated there so that each application doesn't need to do it, which increases the complexity and go
Yeah.
back to the testing case. Like,
Yeah, then you need to have tools on your application store that will be checking that you are correctly calling the CSS
Implementing,
application. So it's a tool to take care of that.
Or you could provide templates as like, the traditional intrusion detection systems provided templates where you could adapt them to your particular use. Just depends on how you want to implement.
Yeah, but the thing is that also most application developer will just not really care, I guess.
Yeah.
I'm maybe not optimistic there, but
it's like asking people to make an HTTPS
Call.
connection. It's still very easy to make it wrong. So as much as we can do to help the applications to decrease the security holes and vulnerabilities, we
I mean,
should.
security is always going to be layered. At every layer you need to provide
Agreed.
something.
Agreed.
never full
It's
security.
never
It's always a
perfect,
layer.
it's not absolute.
I
layer of security.
totally agree. I just think that we should investigate how we can add more layers.
More or less, okay. Cool.
Especially when it's getting just too much.
Yeah.
Other questions? For Sreenu?
One more question.
Sure.
So, have you any plan to support reference fixing engines for Tizen platform? For example, beta state engine, so that any open source developers can utilize and double check whether the virus engines would work or not.
So that is so we have something like an stubbed engine, but it does not because those are all like vendor specific, right? And it also depends upon like because some of it is that is the engines by themselves, they are not open source, right?
Right.
Right.
Even,
Yeah.
even though maybe
Right.
just, for example, 15 days trial version or something.
Okay.
So vendor would be fine. However, the open source individual developers, they cannot, for example, be provided any vaccine engines that can fit to your frameworks. So that's why I'm just suggesting are there any plans to support?
Currently there isn't there, but the stub engines will ensure that like any engine, right, that gets goes on the device would work, right? But what you're looking for is right to make sure that, for example, there is an EICAR sort of virus, right, that is indeed caught, right?
Well, the thing is that there is some open source antivirus solution. So maybe if this API is pushed more publicly, one of this open source solution can be driven to provide some backend.
Well, you know, there's one thing having a backend, which is great, but then the other thing is maintaining new viruses come, they need to be updated, signatures need to be updated.
I know that.
And that,
There is a
Right.
llama, for
Sure,
example,
sure.
providing this kind of thing.
all I'm saying is just the backend is very important part of the story, but it's not the complete story.
Yeah, I completely agree, but there is already open source initiative that kind of fill this gap. So, and if we push this thing, I mean, it should be going outside of Tizen because this kind of thing can get then in that case some open source community to provide this kind of thing.
I think that one thing like for you to take back to the headquarters and figure out if there's a business case for you guys to provide evaluation engine for developers who are registered.
Okay.
Figure out might be a business case for you guys. But I also think that, like Sadiq said, we might need, and what SB was asking for is, we might need a test engine, right? Not just a stub that approves everything, but something that the developer, when he's working with the application and verifying that it did the application correctly, gets to test things working. And this is something that I would hope that you guys can help Tizen project in.
Sure. Good point. We'll look into that. Right.
And then on a third level, we can engage Klamav and other open source and say, hey guys, why don't you provide an engine as well?
Okay. Cool.
Anything else? Okay. Thank you, Sreenu.
Thanks, everyone.